I'm going to walk you through 4 workflows that I've developed specifically related to bridge design using Autodesk Civil 3D 2020 and Dynamo. So the first script that I have is going to report chainage or station information along many locations along an alignment based on user input. So let's go. So what we have in the project is an alignment here that you can see, and I might want to know some very specific chainage or station information based on these 4 curves that I've placed in the model. Back in Dynamo, if I hit run, you will now see that it's put some text in reporting the chainage information for all 4 of those curves. You might want to do this to tell you where the ends of the bridges are, where piles, center lines are. There's a whole range of information relating to bridge set out documentation where you would want to know this information pretty quickly. So let's dive into the script and talk a little bit about how I've done it. So first series of nodes is taking the corridor information from Civil 3D, extracting out the baseline, converting that baseline to polycurve, which is Dynamo geometry. Then I'm flattening that curve down to essentially RL0, and I'm also using layer naming to create the intersection points which will report the station information. So as you can see here, my layer name is Chainage. I've set that up so all the curves that I've drawn here are on a layer name Chainage. It's just a nice way to work. Then what happens is Dynamo takes all that information, intersects it together. If I zoom in over here, you might be able to see those points. There you go. So you can see that in the Dynamo viewer there. And then from out of that information, this node here takes the station offset by point. So when you click here, you will see that there is a series of stations, elevations, and offsets there, which is reporting along that alignment. I'm doing some basic manipulation here to add a prefix for CH for chainage, and then the last node is placing the text back in the model. Pretty straightforward, and that is your end result. You have the ability here to define text height. You can also define the layer name, and you can also set rotation as well, which is pretty handy to let you potentially rotate this text so it's 45 degrees or place it in locations wherever you may need. The second script that I've developed is to determine bearing RLs, bearing pad RLs based on their location in 2D space. So let's say these rectangles here are the locations of the bearings on the project. You want to find out the Z value or the RL where they need to be based on a series of bridge parameters, things like girder depth, hog value, and deck thickness, and all that sort of stuff. So first thing to do is just freeze this off. Freeze. Okay. So the first thing we're going to do is we're going to create a surface inside of Dynamo based on the corridor information that we have available to us. So again, taking the corridor baselines, I'm also selecting the baseline code. I know that it's called Pave1, and then what you get in the model inside of Dynamo is a series of polycurves. I'm extracting out the curves that I need to define 3 locations along the surface, flattening that out, and then just simply doing a surface by loft. The next stage is to take the 2D locations of these bearings and then project it up onto the surface and then determine your RL value. So the way I'm working in this is I'm using layer name called bearing, again just to sort of keep it simple with what we're doing here. So the way I've set this up is I'm getting Dynamo to determine the center point of a circle and use that center point as the point that intersects with the surface above. So as you can see here, I've got some yellow circles that I've drawn, which are in the base, located in the middle of the bearing pad here. I'll just show you one more just to show you how I've located it. So I know that the center line of that bearing pad is the center point of that circle, and it's just an easy way for Dynamo to quickly use that circle as the base location. So if I hit run on that script, you'll see something here has happened in the background. And then when I go back to my view, you'll see that Dynamo has placed some text with a Z value and RL value along each of these locations based on the surface that I've defined over here in Dynamo. So to talk you through it a little bit, I've set up some bridge design parameters here. So starting with the wearing course, 75 thick, I've got the deck thickness, I've got girder depth, I've got any hog values that you may need, mortar pad thicknesses and bearing plate thicknesses. And the sum of this value is the offset, the vertical offset from the surface, and that determines the RL value, which ends up being the text that you see inside the model. So this information here is fully customizable. So if we just zoom over here, if I change this to 2.0 and rerun that script, you'll see that information updates automatically. This is really useful, I think, in early stage bridge design where the design might be changing pretty quickly. The alignment might still be changing, or the bridge itself may be changing. You can quickly calculate your bearing levels for the purposes of documentation or any type of space proofing that you need to do. Again, placing text, pretty straightforward, text height, layer, and in this instance, for rotation, I've just kept it at vector x-axis, which is the x-axis of the project. So my text just comes in, readable in that sense. The third script that I have written, let me just freeze this off. Similar to the last one, but this looks at determining deck levels along a project. So let's say that this is the outline of your deck on a bridge. These lines here could be your pier center lines, and you want to know RL information at each of these corners, also at the intersection points of the deck and the pier center lines, and also at the intersection points of the end of deck and the alignments here. So let me just fix this up a touch. So similar to before, we create a surface based on the feature lines to determine the top surface level, just like I did in the previous workflow. Now over here, again, using layer name as the basis of my scripting. So I'm ensuring that all of the geometry that I'm drawing in Civil 3D is on the same layer called deck. Just makes it easy to manage in Dynamo. This node here, object geometry, is an important one. It takes all of the objects from Civil 3D and converts it into Dynamo geometry to enable you to start manipulating it. I've got a series of nodes here that gets the intersection information of the alignment and the curves that I have drawn in Civil 3D under the deck layer. I've also got the start and the end points of those lines, doing a little bit of manipulation here to remove any duplicates, flattening the lists, and then quite simply projecting the points that I've found straight up onto the surface, and then doing some manipulation again to add an RL prefix and then placing some text. So if I zoom in a little bit here, you should be able to see, let's see, why is this working? There we go. So if I zoom in here, this is the deck curves that I have placed inside of Civil 3D. And then you can see the representative points here that are showing in Dynamo when I use this point.project node. Pretty useful little code block here that you might need to know is if you can pull out, so this point here has an X, Y, and a Z value, so easting, northing, RL. Code block like this, yPoint.y, that gives me all of the Y values. Similarly, I've called it .x, and then down here I've got .z, which is giving me the RLs that I need. Back in here now, you can see the RLs have been placed at all of those points that I need. What you could do here is you could also use Dynamo to extract this information out to Excel. I'm not going to do it, I'm just going to show you the node, export to Excel for use in any reporting or further documentation processes that you may need. And the fourth and final script that I have here is another handy one. I'm sure you could do this with AutoLisp, but I don't know how to write Lisp. And I think this Dynamo script might be reusable over and over again. So what this is going to do is it's going to paste or place a whole series of block references into the model based on an Excel spreadsheet. So let's say that you've received some information from some surveys about existing power pole locations. Let me just hit run. I've done it. Yeah, we define here a Excel spreadsheet that we're going to take the information from, import that data into Excel. What I'm doing here is, why is that not working? Of course, there's technical difficulties when you are trying to do live demonstrations. Let's just go back in here and try again. There we go. So this is the Excel spreadsheet that you might have received from a surveyor with X, Y, Z values based on their as-built pickup. So you can see here that the data has come from Excel, it's into Dynamo now, and these are the values here that represent the Excel spreadsheet. I'm just removing the first row of data, so you will see now that there's no position X, Y, or Z in this list. As just removing that row there, which lets me work with the data a little bit easier. I'm taking out the easting and the northing and the RL information into separate nodes, and then recreating those points by coordinate, which shows all the dots here. And then there's a series of nodes here that lets you define the block reference name and then places that block reference based on their position. So you can see the points here go into the position of the block reference. You can also set layer information, rotation, scale, things like that. And the end result is a whole series of blocks here called power pole, placed at X, Y, Z values throughout the project. So if you click here, you can see the position Z, 42.5, position Z here, 39.68. So they're just a few really quick and in my opinion, really handy uses for Dynamo in Civil 3D. I think it's going to be interesting to see where the developers go with this in the future, and I think when they start to add more functionality and additional nodes to play around with and start using, it's really going to bolster this bolster Dynamo into something that's already stronger than what it is. Thank you.